Okay, so since our topic is about post-well heat treatment, it is very important for a technician to know what are the different heat treatment, no? And in order for you to conduct post-well heat treatment, you need to have a knowledge on metallurgy. Medyo challenge ang metallurgy, but you need to know this. First, I will introduce this iron carbon phase diagram, no? If you take a look, there is a carbon content on the horizontal side, and on the vertical side, these are the different temperature of your metal. Sabi ko sa inyo kanina, up to 2.1%, this is considered as steel. So meron palang phase transformation sa ating material, depende sa maximum temperature na inaabot ng ating welding. What is the maximum temperature of our weldment? So if our carbon content is up to 0.8%, may tinatawag tayo na pearlite and ferrite material, no? But it will transform kapag ang carbon content is between 0.8 up to 2.1%, the pearlite ferrite will be converted into pearlite cementite. Unti-unti siyang tumitigas, no? Habang lumampas na ng 2.1%, these are cast iron, nagiging combination siya ng cementite, nawawala na yung pearlite formation niya, naging cementite na siya. And nadadagdagan pa siya ng ledeburite. So these are the transformation of your bakal, no? These are very important for metallurgists. And if you take welding engineering, so this aspect will be thoroughly discussed to you during the discussion. What is the boundary of this green line? So at a certain temperature, ito, katulad nito at 200 degrees, 400, 600, pagdating ng 723, ang ating bakal habang iniinitan mo, nag-expand.
Sir Gerald?
Yes.
Yung screen nyo po ata parang hindi lumilipat siya.
Hindi?
Hindi po nag-i-slide. Hindi po lumilipat siya sa ibang slide.
Hindi naman ako lumilipat eh.
Okay po.
Nandito, ang aking discussion, andito pa rin sa iron carbon diagram. Okay, first page pa rin. Ayan. Nakikita niyo na?
Okay na ba, sir?
Okay, so sasalita ako, wala palang slide, no? So parang briefing lang sa inyo that there is a iron carbon diagram. So this is iron carbon diagram. So on our horizontal is the carbon content, and the vertical side is the temperature in degrees centigrade. Dito naman sa kabilang side is degrees Fahrenheit, no? So if the carbon content is up to 0.8%, up to this portion, this is pearlite and ferrite. And as you increase the carbon content, it will change from pearlite ferrite, nagiging pearlite cementite. And then itong cast iron, which is 2.1%, nagiging cementite, pearlite, and ledeburite. So
Hello po,
nagkakaroon
Sir
ng iron
Gerald.
carbon.
May questions po tayo, sir. Sagutin niyo po ba muna?
Tapusin ko muna yung discussion ko bago nyo, kasi nawawala yung flow ng discussion. Mamaya after, ha?
Okay.
With regards to this ba yung Tungkol ba dito yung tinatanong?
Yes, sir. Bali joint efficiency at saka yung possible result.
Mamaya na lang tapos okay. So, at this temperature at 723, ang ating material solid. Okay? Kapag yan umabot na sa this, we call this as A1 stage. Ang A2 stage, this one, nakita niyo yung maliit na line na yan, at saka itong green boundary, sundan niyo yung pointer ko. Yan. Yung boundary na yan, kapag lumampas dyan ang material natin, ang ating bakal, solid liquid at that temperature. At kapag naman lumampas, sundan nyo yung pointer ko, no? At this temperature, full liquid na yung ating material. So anong ibig sabihin nun? Hindi lang pala solid ang bakal. Solid ang bakal at low temperature. Pero habang tumataas ang temperature, pwede siya maging solid liquid, pwede siya maging full liquid. Sa post-weld heat treatment, kailangan hindi tayo umabot sa liquid stage. Kailangan umabot lang tayo sa dito sa line ng A1 stage below. At this portion, ang ating steel is red orange, nagiging red orange na siya, no? So, hindi pa siya solid na solid, pero pwedeng ma-release ang residual stress na na-trap sa ating welding during actual welding. So, if we conduct welding at the weld center line, ito yung highest temperature. As I mentioned to you, molten metal siya. Pagdating sa red color, ang kanyang temperature 1,400. Sa orange, nagiging 1,000. And sa bright yellow, dito sa dilawan, 200. So, iba-iba ang temperature na inaabot ng ating weldment. If you will take a look on the right portion of your screen, this is your weldment. Ito yung weld center line. This is the highest temperature molten metal. While this boundary up to this portion, coarse grain and fine grain, umabot siya sa A3 stage. So, ano yung A3 stage? Solid liquid stage. While the number 3 is the area not affected by heat or lower than 723 degrees centigrade. Kapag nag-welding ka pala, nag-create ka ng different grain structure depende sa highest temperature na inabot ng ating material. And usually, this coarse grain material, dito lumalabas ang cracking sa heat affected zone area. Okay? So, if this is our welding, the highest temperature, umabot siya sa liquid stage, while this one on letter C, umabot lang siya sa boundary ng A3 stage, which means solid liquid. And the letter B is up to A1 stage, which means up to 723. And the other areas, malamig na yan. Yung areas na hindi naapektuhan ng heat input. Okay. So, we're creating different grain structure on our weldment habang lumalayo sa ating weld center line. Kaya pwede magkaroon ng failure sa ating bakal. So ano pa yung nangyayari sa ating bakal? Sa A,
Sir, pagka pala nasa
temperature,
B stage, ito yun sir, yung liquid to liquid.
hindi kita naiintindihan.
Hello? Wala.
Hindi kita naiintindihan, Bong. Cannot understand you.
Hina yata internet ko, sir.
So, yung A, yung ating bakal na hindi naapektuhan ng heat is a mixture of ferrite and pearlite grain. These are temperature below 723. And there are small changes in the microstructure. While on letter B, this one is up to A3 stage, solid liquid na siya. So yung kanyang ferrite and pearlite grains are transformed into austenite stage. So na-transform from ferrite, pearlite into austenite. Okay? And this will create normalized material. Ano ba yung normalized material? These are tough material, no? Okay lang siya kasi toughness. There is a certain toughness of your material. But on your letter C, this exceed the solid liquid, naging liquid siya, that transform siya into full austenite transformation. And the letter D is the highest temperature, which create a coarse grain structure. And if cooled down rapidly, and the critical cooling between 800 to 500, ang temperature is 800 to 500, pinabilis mo ang cooling, nagkakaroon ng hard structure or nagkakaroon ng brittle fracture on the area. Kaya dahan-dahan lang dapat ang pagpapalamig between 800 to 500 kasi it will affect the microstructure of your material. So anong nangyayari sa bakal if this is our weldment? Tumataas ang hardness sa ating heat affected zone. Pag mataas ang hardness, anong nagiging effect? Nagiging brittle material. Ano yung brittle? It behaves like a glass. So madali siyang napuputol. So these are the different transformation of your metal from pearlite, ferrite, pearlite, cementite, hanggang naging liquid stage na siya at austenite. At yun namang mga bakal na mataas ang carbon content, nagkakaroon ng leborite. This is a eutectic mixture of austenite and cementite. Okay, Robert, ano yung tanong?
Yung tanong po sir is yung joint efficiency of weld on. Teka lang sir. Yung isa po muna sir, medyo malabo po yung tanong na isa. Anong nangyayari if ang metal laging na-heat treatment? May possibility po ba na tumaas yung brittleness at madaling mabasag?
Teka muna, yung una muna joint efficiency.
Sige sir, ang nakalagay lang po dito sir is joint efficiency of weld on certain material. Yun lang pong nakalagay. Pakilinaw po yung tanong, Sir Johnny.
So hindi malinaw yung tanong pero magpapaliwanag na lang ako, no?
Sige
Ang
po.
joint efficiency formula, ang target dapat dyan ng joint efficiency is at least 1 or 100%. So anong ibig sabihin yun? Kailangan sa weldment, ang design ng yung weldment, kung ang ating bakal, ultimate tensile strength, 60,000 KSI, yan ang ultimate tensile strength ng ating bakal. Ima-match mo dapat yung gagamitin mong electrode. Okay? So kung anong gagamiting electrode kapag 60,000? So meron tinatawag tayo na E6011. So 60 is the tensile strength of your welding electrode. So kung ang ginamit mo E6011, so 60,000 din ang strength ng weldment. So match ang ating strength ng ating parent metal or base metal sa ating welding electrode. So 60,000 divided by 60,000, 1 ang ating joint efficiency. Okay? Eh paano kung ang ating bakal ay 70,000? Mas matigas ang ating bakal, ang ginamit mong electrode 60, that's less than 1. Dapat at least 1 ang ating joint efficiency. So match ang tigas ng bakal at saka yung tigas ng ating electrode. Ang welding inspector at saka welding engineer dinidesign na ang ating joint efficiency is at least 1. Okay, paliwanag ko ba yung tanong niya?
Yes, sir. Apa.
Kahit na malabo yung tanong niya, eh sinagot ko na lang kung ano yung joint efficiency.
Yes, sir. Sumagot po si Sir Johnny. Copy daw po, sir.
Okay? So, yun. Ang pangalawang tanong, may katanungan galing kay Robert.
And sir, from Sir Rian po, sir. Ano daw pong mangyayari if yung metal daw po ay laging nag-undergo ng heat treatment? May possibility daw po ba na tumaas yung brittleness at madali pong mabasag?
Ang aking sagot dito sa susunod na topic natin, the different heat treatment.
Okay, sir.
So, pwede, sir. Pwedeng maging brittle ang material. Depende yan sa heat treatment. Meron tayong 3 parts of heat treatment. First is the heating rate. This one. This one, the number 1 is your heating rate. Mabagal, slow heating, then soaking time and soaking temperature, depende sa material. Ordinary carbon steel in accordance sa ASME Section 8, the soaking temperature is 593 up to 649. So, mahirap namang makita sa time temperature graph yung 649, no? At saka 593. Ilagay mo na lang sa 600. Igitna mo na lang. So, tapos, depende yan sa kapal. For every 1 inch, 1 hour ang soaking. So, yun yung second part of heat treatment. And the third part is cooling down of your material. So, malinaw, no? If we have a heat treatment, we have 3 parts. The heating rate, the soaking temperature, and the cooling rate. Okay. So, ang bakal, pwede mong baguhin ang mechanical property if you control this heat treatment. Okay. The first discussion is annealing. What is annealing process? Meron kayo na, annealed material yan. Ano ang nangyayari sa annealed material? Kung gusto mo ang iyong bakal, soft and ductile. Okay? Pressure vessel. Gusto mo ductile. Yung makuna, yung nag-i-stretch siya bago siya sumabog. Bakit? Ayaw natin na yung bakal sabog kagad. Eh kung ikaw naglalakad sa planta, ang gamit mong material mataas na strength, tapos brittle. Pag nag-overpressure siya, naglalakad ka ron, sasabog, patay ka. Kaya pumili ka ng bakal na may certain ductility, ability of your material to deform or stretch. So may certain stretch bago bumigay. Mag-grow muna bago sumabog. So yun yung kailangan nating material for pressure vessel o pressure tank. May certain ductility. Paano natin magagawa yon? So, sa steel, you will heat this one, slow cooling. Kaya nga dyan sa Boswell heat treatment, okay, pili kayo ng heating rate. Ano yung normal? Mga 180 degrees centigrade per hour or 200 degrees centigrade per hour. And then, isusok natin kung yan ay ordinary carbon steel at 600, 1 hour per inch thick. Kung makapal yung ating material, 2 inches, 2 oras mo isusok. And then, slow down cooling. Ano ba yung slow down cooling? Mga 150 degrees centigrade. So, slow heating, slow cooling. Kapag yun ang ginawa mo, ang tawag doon, annealing process. Ductile ang ating material. Okay? Ano naman yung normalizing? If you notice, same graph siya. Kung 200 yung ating annealing, 200 din yung ating heating rate. Same soaking temperature, 600. Pero ano nagbabago? Ang nagbabago yung tagal ng cooling down. So this one, ito hanggang dito. So mas matagal ang cooling down ng annealing compared sa normalizing, mas maikli. Okay? Kung nag-Boswell heat treatment ka, siguro ang mga cooling down mo rito 200 degrees centigrade. While on this one, pagkatapos mo mag-soaking, patayin mo na yung makina, huwag mo alisin yung insulation, cool in still air. Habang nakalagay pa rin yung ceramic fiber insulation, patayin mo na yung mga heater, palamigin mo on ambient temperature. Ano nangyayari sa ating bakal? Tough material. Magkaiba yung ductile sa tough. Ability of your material to absorb impact energy. Makunat na bakal in Tagalog. Hindi ko alam sa Bisaya kung ano yung makunat. Okay? So, your normalizing will create certain toughness of your material. Kuha nyo ba?
Yes, sir. Apo.
Ano naman yung quenching or yung ibang tawag dito hardening? Same heating rate, 200. Same soaking temperature. Kaya lang ito, basain mo ng tubig, basain mo ng oil. Pag oil quenching ang tawag doon. Pag water quenching. Ano nangyayari sa ating bakal? Tumataas ang hardness ng ating bakal. So, magkakaiba, no? Annealing will create ductile, mechanical property. Normalizing will create makunat na bakal or toughness material, while quenching and hardness will create hardness of your material. So ito yung mga pwede mong gamitin sa mga quenching, mga moving parts, no? Na nagkakaroon ng friction. Teka lang, low bat ako ha. Kunin ko yung charger ko. Robert, alawin mo muna sila. Kunin ko lang yung charger ko.
Sige po. Hello po. So habang inaantay po natin si Sir Gerald, magtanong na lang po muna tayo ngayon. Sayaw ka muna. Sira yung camera na ito, sir. Ako. Sige sir, tanong lang po muna kayo kung may mga tanong po kayo. Especially regarding po sa ball mill application.
Hello.
Hello po.
Robert, naririnig mo ba ako?
Yes ma'am, po.
Sayaw ka muna.
wala po tayo talent dyan. So far, okay naman po ba ma'am? Lahat po na intindihan niyo naman po lahat.
Okay, okay lang, okay lang.
Okay po.
Medyo slow lang yung internet connection namin dito.
Pag may hindi po malinaw ma'am, don't hesitate po na ipaulit po sa instructor natin yung part na yun, lalo na kapag medyo critical po yung topic.
Okay, Robert, nakabalik na ako.
Okay
Sige
po.
po, noted po.
So I already explained the difference between annealing. Annealing will create steel which is soft and ductile. Normalizing will create a steel which is a tough material, and hardness or hardening or quenching will make the steel hard material. So these are the three heat treatment process that will change mechanical properties such as ductility, toughness, and hardness of your material. And the fourth one is tempering. So ano ba yung tempering? You will balance toughness and hardness, no? So if you want to balance the toughness and hardness, you will save din ang heating rate, no? Mabagal na heating rate. Kaya lang, kung ang ginamit natin sa annealing, normalizing, and quenching is 600 degrees centigrade, this one, mas mababa ang temperature. Usually, in my experience, these are on the range of 400 to 450 degrees centigrade, no? So, instead of 600, ang tempering, mababa ang temperature. Mga 400, no? Dito sa lecture natin, between 200 to 723. But by practice, ang pina-follow ko mga 450 or 400 degrees centigrade in order for you to have a maximum balance, toughness, and hardness. So we have 3 or 4 heat treatment: annealing, which create ductility, normalizing, toughness of your material, and the hardening or quenching, hardness of your material. If you want to balance between toughness and hardness, that's tempering. Okay, so you buy or you bought a post-weld heat treatment, and your post-weld heat treatment can perform preheating, no? So ano ba ang preheating? So preheating is slowing down of your cooling, no? Para maiwasan natin yung hardening effect. Kasi habang binabagalan mo yung pagpapalamig, nagiging soft and ductile nga, no? Naiwasan natin ang cracking. Ba't ba nagkakaroon ng crack sa ating welding? Pinabibilis natin yung crack, yung cooling down. Masyadong lumamig ng mabilis, 1,400, tapos na-expose sa masyadong malamig na temperature condition, therefore, cracking will occur. So, ang preheating rin is helping diffuse hydrogen. Ito yung pinaliliwanag ko kanina na binibake out natin yung hydrogen para lumabas sa welding, hindi matrap sa loob ng ating weldment at saka heat affected zone. So maiwasan dyan yung cold cracking or hydrogen induced cracking or HIC, hydrogen induced cracking. And it also, preheating also slow down the cooling and avoid distortion of your material. So naiwasan din ang distortion sa ating material. And this one, di-discuss ko sa inyo thoroughly mamaya on another slide. The post-40. So, aalisin natin yung residual stress na trap sa ating weldment during welding operation. Dahan-dahan nating initan, slow heating, then soak at 600 degrees centigrade, and then slow cooling in order for you to release residual stress on our weldment. This one I discussed thoroughly. So these are the summarized portion of your different heat treatment, no? So the first one, please follow my pointer. Slow heating, soak at 600, and ang bagal ng cooling down. This one is annealing. This one, no? So nagbabago lang sa pagpapalamig yung tatlong heat treatment process, no? Kapag sobrang bagal, ductile. Then yung second naman, pinalamig sa ordinary air, normalizing. Ano naman ang hindi sobrang bagal ang pagpapalamig? Pinalamig at normal room temperature, pinatay ang heater, ano nakikreate? Toughness of steel. And ito naman, after 600, inabot na yung 1 hour, binasa or tinubog sa oil, ang tawag dyan, quenching. Hardness naman. While if you notice, mababa ang temperature at 400 degrees, then slow cooling, this will balance toughness and hardness. Okay? Pwede rin namang i-quench mo siya, then palamigin mo siya, and then itaas muli at 400 degrees centigrade, ang tawag dyan, combination ng quenching and tempering. So, this means by heat treatment, you can change ductility, which is annealing. Normalizing will change the toughness, and hardening will change, or quenching will change hardness of your material, while tempering will balance toughness and your hardness. So these are the different heat treatment and the different mechanical properties that you will achieve during heating and cooling of your material. Okay.
Sir Gerald,
Yes.
sir, yung PWHC or yung stress relieving, saan siya pumapasok na process ng heat treatment, sir? Tempering, annealing, or
Home annealing process.
annealing? Sige.
Ngayon, kung gusto mong may certain toughness pa rin, yung tuwa o yung cooling down mo, wag mo masyadong bagalan kasi nagiging ductile siya, no?
Buong.
Gawin mo 250 para meron certain toughness.
Wala pa.
Okay, tuloy ko na.
Okay, sir.
may tanong pa po to dito, sir. Sagutin niyo po ba muna, sir?
Jeb, mo invite na to. Like, si Jeb.
Yan. Meron na silang sound. Exciting na.
Sir, ito pa may tanong po. Sir Gerald?
Sige, tanong.
Sige po. Sa aming ball mill po, may thickness siya na 95 mm and 80 mm. Ang soaking time namin na in-input ay 2 hours lang. Okay lang po ba yun?
Okay, 1 inch per thickness. Almost 4 inches yun, di ba? Dapat 3 oras mahigit.
Okay po, sir. Ito pa po,
Bakit?
sir.
Bakit? Bakit? Ito drawing ko.
Sige po.
Para parehas ang temperature. So magdodrawing ako no. Halimbawa, ito yung ball mill mo. Sabi mo ang kapal nito ay Robert ilan?
95 mm thickness, sir.
95 mm.
By 80 mm.
O kaya 80 mm o 90 almost 4 inches na yan. Ang heater mo, ceramic pad mo nandito sa ibabaw, di ba? Di ba?
Yes, sir. Sa may bandang ano po.
Kung 1 oras, 2 oras, baka hindi ka sigurado na ang temperature na 600 sa labas. Pero sa loob, dahil maikli pa lang ang soaking, baka hindi rin 600. Ang target kasi natin, dapat ang temperature sa ibabaw ng heater, tsaka sa loob, pantay, the same temperature. And we will attain uniform temperature if we achieve the desired soaking time on your material. Kaya if this one is almost 4 hours or 3 hours, sigurado natin 600 sa ibabaw ng material and then 600 din. Baka kung 2 hours pa lang, baka 580 pa lang yan. So your time of temperature will ensure habang kumakapal ang bakal, yung heater natin, source ng heat, nasa ibabaw lang. Para maging uniform yan all throughout the thickness of your material, you need to achieve for every 1 inch, 1 hour soaking. Or for every, yan ang formula. So dapat doon 3 hours mahigit ang soaking time.
Okay po, sir. Yan. Ang 95 mm daw po nila, sir, ay tama po, 3 hours and 8 minutes po pala dapat. Yun po dapat daw, sir.
Okay. So, yun ang dapat procedure natin. Robert, can I proceed? Any other question?
I think, sir, pwede na po. Yung isa po kasi, para nasagot na rin po kasi ang nakalagay po dito is yung 1 hour na soaking time, standard po ba yun or depende po sa material?
Standard yun sa carbon steel, 1 inch per thick. Pero kapag chromium molybdenum,
Okay po.
2 hours per inch thick. High alloy steel. Okay? Based
Okay po.
on ASME Section 8.
Sir, pa-repeat po.
Yes, ma'am.
Pa-repeat po ng sagot nung sa standard ba yung 1 hour na soaking time.
1 hour soaking time for ordinary carbon steel. But for, as I mentioned to you this morning, there are high alloying element and low alloying element. For different materials, chrome moly, high alloy steel, 2 hours per inch thick. Ano ba yung ball mill nyo? Kung ang ball mill nyo is ordinary carbon steel, 1 hour per inch thick. Pero if you have other material na chromium, molybdenum, 2 hours po ang per 1 inch thick.
Okay na po, ma'am.
Okay po, noted po.
Okay. So why do we do post-weld heat treatment? Or in general term, this is called as stress relieving. So if we introduce welding sa ating material, you are introducing high residual stresses sa ating metal. Bakit? Allow me to draw, no? So if this is our plate, sample lang. And we're conducting weldment. So ito yung ating weldment, no? Robert, nakikita ba? Saan ang pinakamataas na temperature? Where is the location wherein the temperature is the highest? As I mentioned to you kanina during my presentation, the highest temperature is on the weld center line, on the center of your welding. Okay? This has the highest expansion of your metal. And because this one is expanding, the direction is towards outside our material, no? While the base metal, habang lumalayo siya sa welding, lumalamig siya. There is a contraction on the metal because this one at 1,400, while on this metal naman, habang lumalayo sa welding, pwedeng mga 200 na lang, no? So, ano nangyayari sa physical property of your metal? There is a contraction. So if this one is expanding on the outside force, your material is contracting inward direction naman. So therefore, you have two opposite forces on your weldment. Merong expanding, mataas ang expansion sa center line. Sa atin namang base metal at low temperature may contraction. These two opposite forces, we call this as residual stress. And if you cool down very fast, this residual stress will be locked inside our welding. So therefore, you need to remove this locked-in residual stress on our material by slow heating, soaking, at if you soak the material, natatanggal na yung residual stress on your material. Bakit? Ano bang ginagawa ng residual stress on our metal? It could reduce toughness. Pwedeng magkaroon ng brittleness on our material na will create brittle fracture. Kaya ang stress relieving will reduce fracture toughness, yung kabaliktaran ng brittle fracture. So inaalis natin yung possibility of brittle fracture on your material. And habang tumatagal, nag-ooperate tayo, tumatanda ang bakal. Like people still will also encounter fatigue. And if your steel reach the fatigue strength or endurance limit, it could fail at any time. In order to prolong life post-well heat treatment or stress relieving will be susceptible to corrosion and the combination of stress and corrosion cracking. So therefore, post-well heat treatment can also avoid stress corrosion cracking or SCC cracking. And usually post-well heat treatment is applicable for carbon steel or carbon manganese material. And there are numerous codes. Meron BIS, British Standard, ASME code, Japanese Standard, Canadian Standard. So meron dyan standard na nagsasabi ano yung soaking temperature ng ating material. And usually for carbon steel, this stress relieving soaking temperature is between mga 580 to 650 or yung exact is 593 to 649 degrees centigrade. And if you take a look on the picture, there are ceramic pads, and if our temperature is at 600 degrees centigrade, this is the color of your metal. This one, your metal is hindi pa siya nasa liquid stage. Hindi rin siya totally solid, but in between solid and liquid. Kaya ingat kayo, baka ma-deform yung material, especially yung mga thin thickness. So in your application, you mentioned 80 mm ang thickness ng ball mill. So hindi masyadong problema ang deformation. But you need to install support, because stress relieving at high temperature will make your metal behave like a clay. So if you remember during your elementary kinder days, you have a clay, no? Ganun na formation ng ating metal habang tumataas ang temperature. So this one is the tempering, no? The tempering is combination, or you need to balance toughness and hardness, and you have different temperature, tempering temperature 100 to 200. This is low temperature process tempering. The medium temperature is 200 to 500, while the high temperature is 500 to 700 degrees centigrade for low alloy steel. Okay, so normalizing, ito yung nabanggit na kanina na you need a tough material, toughness with certain toughness, and normalizing is cooling on steel air or normal ordinary air. So this one, cooling in steel air or slightly agitated air. And this will normalize the grain structure compared to your annealing with fine grain into a normalized material. So if you compare annealing and normalizing, you have a slightly harder steel on a normalized compared to your annealing, which is soft and ductile material. Okay, so if you conduct post-well heat treatment, make sure we follow the soaking temperature, no? Kasi if you exceed the soaking temperature, halimbawa soaking time mo 600 to 650, lumampas ka ng 650, there is a risk that you lose strength of your steel. Kaya very important for you to follow the heating rate, soaking temperature, soaking time, in order for you to prevent loss of strength on your material. So these are the risks if you exceed temperature and time on your heat treatment process. Second effect is if you're heat treating a thin material, yung mga manipis na material, and there is a possibility of over temperature, therefore buckle or distortion can occur during heat treatment. So make sure to follow the heat treatment temperatures, heating rate, soaking time, and soaking temperature. So may drawing lang ako na kailangan sa inyong ball mill, no? If you have a ball mill, anong diameter ng inyong ball mill? Robert, anong size ng ball mill nila? Estimate mo lang. Robert. Wala. Anyway, kung halimbawa ang iyong ball mill is 2 meters sa diameter, masyadong malaki, no?
Yan,
And
mga
then-
2 meters, sir.
Ilan?
Mga 2 meters nga po yun.
O,
Ayan,
kung
4 to
2
5 meters daw po.
Okay, alam mo, malaki nga yung diameter, no? At kailangan uniform ang temperature. Kung halimbawa, nandito yung crack area, no? Andiyan sa taas, at 12 o'clock. Kung titignan mo yung iyong watch at 12 o'clock, make sure that you have even temperature all throughout. Kung iinitin mo yung buong ball mill, lalagyan mo ng ceramic pad, walang problema, no? Lalagyan mo ng heater, babalutin mo yan, walang problema sa temperature gradient. So kung ang crack mo na sa ibabaw, at least sana yung heater natin o yung ball mill natin, makover natin at least 1/4 of the area of your material. Para, kasi ito 600 sa soaking temperature, no? Tapos itong ilalim ng ball mill mo, wala namang heater, malamig. Eh di nasa ano yan, nasa ano ba, 200 degrees centigrade. So malaki ang temperature difference from 600 to 200. Diba? Ang excessive ang kanyang temperature difference or temperature gradient. So ginagawa namin dyan, kapag nandito lang heater, laparan mo yung pag-apply ng heater and then balutin mo ng ceramic fiber ang buong circumference of your ball mill para hindi masyadong mataas ang temperature difference from your 12 o'clock to your 6 o'clock. So ini-spread out natin yung ating temperature, and as much as possible, you need to install additional thermocouple wires in order for you to monitor the temperature on the side of your weldment. Halimbawa, andito lang yung repair mo. Halimbawa, ang size ng repair mo, 3 inches lang. Tapos lalagyan mo lang ng isang ceramic pad. By practice, sayang naman yung makina mo. Ang makina mo, yung binili yung makina, kaya niyan up to 18 ceramic pads. So you might as well install 5 to 6 ceramic pads in order for you to avoid temperature difference between the top portion and bottom portion. Kasi buti na lang makapal lang yung ball mill, 80 mm. Kasi kung manipis yan, kakaroon niya ng distortion or warpage. Kaya pag kayo magko-conduct ng repair, huwag lang isang ceramic pad. Gumamit ka na ng 5 to 6 ceramic pad, then yung area ng paglalagyan ng installation, hanggat maaari, laparan mo na rin para to avoid excessive temperature gradient. And the third is prevent embrittlement or too much hardness. O yan, pag nabasa yung inyong heat treatment, titigas yan, therefore nagkakaroon ng embrittlement. Make sure na we follow the heat treatment procedure in order for us to avoid embrittlement or cracking on your material. So these are the three risks that could happen if you exceed temperature, pinabilis mo yung cooling down, konti lang yung ceramic pad na ginamit mo. So that are the three possibilities that you may encounter for your post-well heat treatment. So I already finished the topic on heat treatment. Una kong discuss the different chemical element that affect mechanical properties of your material. The second is the different heat treatment. I will now proceed to the heat treatment process. Okay, this is our weldment, and if we apply heat on our weldment, the highest temperature is on the center line of our welding, and our pen metal is medyo malamig, and if it cool down, it produce residual stresses on our material. Okay, so these opposite forces will produce residual stress on our material. And same with pipes or other shape of material. On the weld center line, you have the highest temperature, and two opposite forces will create residual stress that will create hard brittleness or residual stress that will create crack on your material, and weld failure can occur if we have residual stress on our material. So these are our weldment, and we are encountering different temperatures. So therefore, in metallurgy, you are creating different grain sizes of your material. And the purpose of first preheating is to slow down cooling, to avoid stress and brittle hardness on our weldment. Okay. And preheating also remove hydrogen in our welding that can create porosity, and this porosity, if aligned to each other, can create weld cracking on our weldment. So the reasons why we do preheating, especially for high carbon steel and low alloy steel, is to avoid the risk of cracking and reduce hardness of your material. So we don't need a material which is very hard like a file. So we need to slow down the cooling in order for your material to be malleable and ductile. So the next reasons why we do preheating is to remove hydrogen inside the weldment, and this hydrogen can create delayed cracking or cold cracking. So we need to diffuse hydrogen by preheating our metallic structure. So these are the trapped hydrogen gas. If it solidify inside our weldment, this can create cold cracking on our material. And preheating also reduce thermal stresses, the change on expansion and contraction of your metal, and this will have thermal strain on our molten metal that could also create cracking on your material. So preheating reduce fast cooling. So this also to remove transverse cracking, toe cracking, and underbit cracking if you perform preheating on the material. And it will also remove hydrogen-induced cracking, especially on your heat-affected zone. So if you're conducting welding repair for thick material, so very important for you to conduct preheating on thick material in order for you to have uniform temperature on the surface and also on the other part of the test specimen. So however, preheating only reducing the harmful effect such as brittleness and stress, which are caused by welding process. To totally eliminate hardness and stress, it is often necessary to perform heat treatment. Ito yung sinasabi kong stress relieving or the post-weld heat treatment. So ano ba yung setup, no? I interview Robert and I talked to Bong Subida. Robert and Bong Subida actually went to your facility, and I assume they teach you how to attach thermocouple on your weldment, no, by using the thermocouple attachment unit. And then lalagyan nyo yan ng thermocouple putty. Then after that, so your thermocouple wire has a positive and negative, no? And this is from your test specimen. This is the hot junction, ang tawag namin dito, hot junction. From hot portion up to cold area, there is a potential difference in terms of millivolts. And this potential difference is converted into a temperature such as degrees centigrade, actual temperature. So this is your dito nyo itinak yung inyong thermocouple wire. There may positive doon, yun yung chromel, and then yung aluminum is negative. This is the type K thermocouple wire connected to your recorder. And on your time temperature recorder, you will monitor the actual temperature of the material during post-weld heat treatment or preheating process. So once na-attach na natin yung thermocouple wire, then we install ceramic heater or ceramic pad. You will cover this with insulation blanket or the ceramic fiber insulation. So as I mentioned to you kanina, as much as possible to avoid temperature gradient in order for you to avoid distortion. So kailangan balutin natin yung ating material with enough insulation. Kapag yan hindi enough yung insulation mo, hindi tataas ang temperature. Kapag nag-set ka na up to 600, may possibility hanggang 550 lang ang iyong aabutin. Or minsan up to 400. Kapag 400 lang ang inabot ng temperature, wala nang way. Kundi ulitin mo, dahan-dahan mong palamig, and then ulitin mo yung pag-install ng ceramic heater, dagdagan mo para mas maraming source of heat. Okay? Pero kung ang temperature lang, requirement mo 600 degrees centigrade, at ang temperature mo maximum umabot ng 580, 20 degrees na lang, no? Pwede yun, i-extend mo lang yung soaking temperature, soaking time. Kung 580, wala ka nang magawa, yung machine naka full capacity. At yun ang maximum na naabot ng temperature. So, pinapayagan nyo ng code, i-extend mo ng another 1 hour, or sometimes kung ang soaking time is 2 hours, gagawin mo 3 hours in order for you to attain full stress relieving of your material. Ang limitation lang hanggang ang difference 550. Pag more than that, then uulitin mo yung pagse-set up ng heater, dagdagan mo, and then dagdagan mo rin yung insulation in order for you to attain full PWHT of your material. So itong setup dito, preheating, pag nakapagbalot na yan, ikakabit na lang natin yung ating mga heater at saka thermocouple wire sa ating machine, then ready na ang mga welder na mag-welding. Tawag dyan, preheating. So this is the actual setup. Ito yung ceramic fiber insulation natin, and sa ilalim niya may mga heaters. And then ito, mainit. So mainit yan habang nagwe-welding in order for you to remove possibility of porosity on your material. So this is the actual preheating picture conducting preheating of your weldment. So in accordance sa ASME section 5, these are the required temperature for preheating. For P1 material, carbon steel, the preheating is up to 175 degrees Fahrenheit to, no? For P3 material, which is 0.5% chrome, required din yan ng 175 degrees Fahrenheit. For 2 1/4 up to 10% chrome, ang preheating temperature is up to 400 degrees Fahrenheit. So different material group has a recommended preheating temperature based on ASME boiler and pressure vessel code. So after the preheating, post-weld heat treatment naman, ano ba ang function ng post-weld heat treatment? To slow down the cooling and to remove residual stress. And post-weld heat treatment also improve machine stability. So anong ibig sabihin nun? If your material will be subjected to machining, kapag na-machine mo yan at na post-weld heat treatment mo siya, walang distortion na mangyayari kasi nawala na yung residual stress. So this one may PWHT, this one walang PWHT, kaya nagkaroon ng deformation. Therefore, if you're conducting machine stability, if you want to achieve machine stability, better to undergo post-weld heat treatment. The second function is to avoid distortion, no? Para uniform yung ating. So these are distortion that will lower down fatigue strength of your material. So in actual, if you remove the weldment, so nung lumamig na yung weldment natin, mas maikli kaysa sa shorter than our base metal, no? Because there is a residual stress inside our material. So in order to remove this, you need to conduct post-weld heat treatment. And post-weld heat treatment will lower down ductility, more ductility, and lower down the hardness of your material. So annealing will contribute more ductility on your material. And the third function of post-weld heat treatment is to avoid brittle failure, especially if you are conducting thick plate welding on your project. This could fail due to brittle fracture. So if you conduct post-weld heat treatment, maiwasan natin na ma-attain ang brittle fracture of the material. So if you notice, very fast ang cooling nito, mas mataas ang hardness. This one is low cooling, so soft and ductile material. And if your material is on a chemical plants, and there is caustic chemicals on your material, it will prevent caustic embrittlement if you conduct post-weld heat treatment. And over a period of time, combination of stress corrosion cracking can occur on your material, especially on hot caustic alkalines, nitrates, carbonate, ammonia, cyanide. This will attack steel. And therefore, if you conduct post-weld heat treatment, maiiwasan natin ng caustic embrittlement. Okay, so they have higher resistance to the attack of these different chemical contents inside, and it will reduce the residual stresses inside our weldment. So if we have a post-heat treatment welding, this is better. It could avoid caustic embrittlement compared to a weldment without post-weld heat treatment. So it will improve the corrosion resistance, and your life of your weldment will be extended if you conduct post-weld heat treatment. Especially if it has a repeated load that will create fatigue resistance. So if you conduct post-weld heat treatment, it will prolong the life of your weldment. So failure of your weldment, apart from metallurgical reasons such as void, is usually due to one of these three types of loading. So static loading, repeated loads, and combination of loading at a certain temperature will create brittleness. Yung repeated load naman, aabot siya sa endurance limit. While yung static load, beyond its ultimate strength, tensile strength. If you conduct post-weld heat treatment, may iwasan natin these problems, the brittleness, the endurance, and the exceeding to the ultimate strength of your material. And post-heat, improve fatigue life of the weld. A small decrease in allowable stress will give large increase in the life of your weldment. So, mas pinaprolong ang life ng ating weldment if you conduct post-weld heat treatment. Okay, so this is the electrical resistance method, the ceramic pad, no? So, sa post-weld heat treatment, tapos na yung ating weldment, maglalagay tayo ng number of thermocouple wires. For every 3 ceramic pad, at least merong isang thermocouple wire. The more thermocouple wire, the better for you to have temperature monitoring. So after the attachment of your thermocouple wire using the meron diyang thermocouple attachment unit, yung TAU, by capacitant discharge, you will place enough ceramic pad. Kailangan hindi masyadong malaki yung space in between 2 ceramic pads para uniform ang temperature. Pinakamalaking gap is 1 inch. And then, install ceramic blankets hanggat maaari hanggang malaparan natin yung area para maiwasan yung too much temperature gradient. Then connect this to your heat treatment machine. So this one, so i-connect natin yung heater sa ating machine, and then yung ating namang thermocouple wire connected to our programmer and our temperature recorder. Once na set up na yan, then you will follow the heating rate, soaking temperature, soaking time, and then cooling down. So ang nabili nyong equipment is a programmable equipment, which means you will just input the heating rate, input the soaking temperature, and soaking time, and the cooling down process. Kung tama ang pag-install nyo, then tuloy-tuloy na yan until magkaroon ng slow down cooling. So, make sure na ang ating kable hindi naka-coil, kasi pag naka-coil yan, nag-iinit. Para siyang nagiging electrical resistance na rin. Kaya dapat naka-stretch. So this one is an example of a heat treatment unit with temperature recorder. And this one, the programmer. On the programmer, you will input the heating rate, soaking temperature, soaking time, and the cooling down process. So this is an example of a 50 kVA, which means 6 channels. So 1, 2, 3, 4, 5, 6. On each channel, meron 3 ceramic pads. On each of every 3 ceramic pad, 1 thermocouple wire. And your power supply is 440 volts, 3-phase, 60 amperes. And this one is 32 volts for safety, no? Mababa lang yung voltahe niya. And our ceramic pad is a 65 volts ceramic pad with 70 amperes. Okay, that's the dimension of your machine, and your machine is almost 300 kilos and 6 control zones for a total of 18 ceramic elements can be installed. So this is an example of your programmer. I think this is a different model of a programmer. And this one is a temperature recorder with chart. So the chart is the evidence that your material undergo the different temperature requirements. This one is a thermocouple attachment unit wherein you will attach the type K thermocouple wire to your material. Low heat input para hindi magkaroon ng additional change in mechanical properties given by heat, too much heat in our material. And these are different ceramic element, ceramic pad, depende sa size, no? May CP8, CP11, CP12. So, and this is the actual post-weld heat treatment temperature at 600 degrees centigrade. Okay. So many different sizes of ceramic elements depende sa inyong requirement. And this is a thermocouple wire, red and yellow with positive and negative polarity. The ceramic fiber insulation, the power connectors, usually ito yung mga pinapalitan sa equipment. So, mag-stock na lang kayo if in case masira yung equipment nyo. So these are thermocouple plugs also. Thermocouple putty in order to avoid direct heat pick up sa ating heater at ang makuhang temperature, yung actual temperature sa metal. So this is an example of a heat treatment procedure na ang heating rate 150 degrees centigrade per hour. Soaking temperature is 593 to 649. Soaking time 1 hour and 25 minutes. So mas makapal yan sa 1 inch siguro. The cooling rate is 200 degrees centigrade. So if you follow and after 150, pwede mo nang patayin yung equipment. So this is the example graph following your procedure. So for every hour, 150 degrees centigrade ang takbo ng ating heating. Another hour, nasa 300 na siya kasi 150 per hour. So at 2 hours, nasa 300 na siya. At 3 hours, nasa 450 na siya. Until 4 hours, na-achieve na natin yung 600 degrees centigrade. So we finish the heating rate after 4 hours. Then we need to soak at 600 at 1 hour and 25 minutes. So may konti pa sobra yan ng 25 minutes. And then cool at 200 degrees per hour. So from 600, after 1 hour, dapat nasa, kasi 200, 400 na siya. Okay, so kasi 200 ang kanyang cooling down. Another 200 for 1 hour, nasa 200 degrees centigrade na siya. Okay, at maghintay na lang tayo ng konti para umabot ng 150, then off na yung ating equipment. So this is the time temperature graph of the complete heat treatment procedure with 150 degrees centigrade per hour. So ang ating heating rate inabot ng 4 hours. Ang ating Soaking at 600, dapat yan 1 hour and 25 minutes. And then ang cooling down up to 400, inabot ng 2 hours. So the total heat treatment cycle is more than 7 hours in order for you to achieve the complete stress relieving removal of your residual stress on our wellhead. Okay, what are the standards? So carbon steel, so depende sa thickness, required i-soak ng 1,100 to 1,200 degrees Fahrenheit. So sa degrees centigrade yan, 593 to 649. Okay? Yan in accordance sa process piping. Sa boiler piping, ito naman ang requirement. Pero halos parehas lang. No? So, P3 material, this is the requirement. If you notice from 1,1 to 1,2, naging 1,1 to 1,325. So, habang tumataas ang carbon content, slightly nag-i-increase din ang soaking temperature. So, this for 2 and 1/4% chrome, 1,300 up to 1,400 na yung kanya degrees Fahrenheit. 1 hour minimum at ang kanyang maximum brittle hardness is 241 BHN. So different material, different temperature, sinasabi yan on different codes and standards. This is an example of an actual post-weld heat treatment with a post-weld heat treatment machine. Okay, so actually we're from CIFRA Marketing Corporation, and I hope with this lecture, it will help you to understand what is the purpose of conducting post-weld heat treatment. Do you have any further questions?
Yes, sir. May mga tanong po tayo dito.
Sige.
Sige po. Dun po sa isa, sir, from Sir Christian Sabala po. Ano po ang mangyayari sa material if kulang po ang soaking time?
Ayun na yung nabanggit ko sa iyo, no? Di ba? Kung 600 ang soaking mo, tapos kinulang ka ng 20 degrees centigrade, pwede mong i-extend. Kung 1 hour lang ang soaking, gawin mo 2 hours. Pero allowed lang yan sa code if mga 50 degrees ang kulang. Ano ba hanggang 550? 550 lang ang maximum, 600 ang soaking, pwede ka mag-extend ng soaking time. Pero kung ang kulang 100 degrees centigrade na, palamigin mo din, ulitin mo ang setup.
Okay po, sir. Next po, from Sir Rian po. Mild steel plate ang ball mill namin. Ano po ang melting point temperature?
Ano, Robert?
Mild steel plate po ang ball mill namin, sir. Ano daw po ang melting point temperature?
Kunin mo yung carbon content, tapos pumunta ka sa table ng iron carbon diagram, malalaman mo yung melting temperature depende sa carbon content. So, kunin eksakto kung ilang percent ang carbon. Then titignan natin sa iron carbon diagram. Pero nagtataka ako, bakit tinatanong niya melting temperature? Sa post-weld heat treatment, hindi mo kailangan umabot sa melting temperature.
Yes, sir.
Kailangan below ka ng 723 or hindi ka, kung ito ay ordinary, isa lang naman ang classification ng carbon steel, whether it is a mild steel, ang soaking temperature is up to 650. Huwag mo na palalampasin ng 650 kasi pag in-exceed mo yan, as I mentioned to you, habang tinataasan mo, naging 800, nababawasan ng strength ng ating bakal. Second,
Yes.
ma-deform. And third, aabot ka na sa melting temperature, baka yung ball mill mo, ma-deform na. Kasi, abot ka na sa melting temperature.
Okay po. Next question po from Dapper Serla. Ano po ba ang tamang paglagay ng ceramic pads sa T-joints with both sides ay may nagawang repair?
Drawing tayo. Hindi ako makapag-drawing. Bakit kaya? Hindi, teka. Ito ako magsusulat. Magamit ang pen. Hindi naka-highlight yung pen eh. Anyway, teka. Magdodrawing na lang ako. Robert, tingin malinis na bond paper. Drawing natin. Bakit hindi ako makapag-drawing dito? Ay, hindi ko kita. Teka, nagkakaroon ng problema sa pagdodrawing. Robert?
Yes, sir. Tawagin ko po si Sir Angelo.
Hindi, teka. May nakita na ako itong pen. Annotate. Okay. So, sabi nila T-joint, no?
Yes, sir.
May nakikita kang drawing?
Apa, yes, sir. Meron po.
So, yan ang anong tanong niya?
Ano daw po ang tamang paglagay ng ceramic pads kapag may nagawa pong repair on both sides daw po? Sa T-joint.
So, maglagay ka ng heater on the top portion. So, lagyan natin ng ceramic pad to. Then, also on this part, maglagay tayo. Also on this part. Okay? Okay. So, this portion, kung ang kasya dito sa top portion, dalawa. So, maglagay ka ng isang thermocouple wire. EC1. So, ito connected sa channel 1. Saka ito. So, sa channel number 1. Ito naman, kung kasya rito, isang ceramic pad lang. So, maglagay ka ng isang thermocouple wire dito. And then, this one connected sa channel number 2. This one, kung isang ceramic pad lang yan, lagay ka ng TC3, thermocouple number 3, ito thermocouple number 2. Yan. Then this one, connected sa channel number 3. Okay. O since meron ka pang extra 6 ang channel ng iyong ceramic, ng iyong heat treatment machine, pwede ka pang maglagay dito ng ceramic pad. So, maglagay ka ng thermocouple wire dito, TC4. And then channel 4. So, ganyan ang pagkabit ng ano mo. So, ang isang channel, 3 ceramic pad ang kasya, no? So, channel 1 sa top portion, channel 2 on the side portion, channel 3 on the another side, and kung meron pa rito area, lagyan mo pa ng isang ceramic pad, then, syempre, balutin mo yan ng ceramic fiber insulation. Kung kayang buo, kailangan walang sisingaw na magandang pagkakabalot. Yan, Robert.
Okay po, sir. Bali, as per Sir Rian po, madalas daw pong lumalabas kasi yung crack sa may channel 3 daw po. Sa may weldment na 95 mm shell thickness at 80 mm sa flange and crack nasa joint weldment daw po.
Dito sa drawing ko, ang sample niya, meron lagi raw crack.
Apo, dyan po. Sa may flange daw po.
Okay, yun nga, kailangan nga, pag ang temperature kasi rito, 600, dapat dito 600 din para uniform ang temperature.
Yes, sir.
Kaya nga meron pang kada ceramic pad, thermocouple wiring para uniform ang temperature. Hindi pwedeng dito 600, dito 580, tapos dito 400, may iiwan to. Kung ito ay 400, sumisingaw tong area to. Doblehin mo ang pagkakabalot dito sa area to. So, importante na ang iyong graph pare-parehas ang temperature sa taas, sa baba, at saka sa kaliwa at sa kanan. Kapag may naiwan dyan, ay magkaroon ng crack sa ating material. Kasi naiwan yung temperature, hindi uniform. Imagine, lalo-lalo na kung 600 dito, tapos dito, walang heater, 200 lang. So, ang laki ng temperature difference. Almost 400 degrees centigrade. So, yung tao nga, if person, galing ka sa aircon na room, tapos biglang lalabas ka sa mainit, maapektuhan ka rin. Ganun din ang bakal. You need to have a uniform temperature in order for you to avoid cracking of your material.
Okay, sir. Another question po. Saan daw po ba dapat i-attach si thermocouple, sir? Sa ceramic pad or sa metal daw?
Sa metal, hindi sa ceramic pad.
Yes, sir.
Kaya makukuha mong init na ceramic pad. Ang importante mong ma-monitor yung init sa ating bakal. If you place the thermocouple wire on your ceramic pad, that's the actual temperature that we need to know. We need to know the actual temperature sa ating bakal. If for example, sample, meron tayong makapal na bakal. Okay, andito yung heater natin. Dito natin nilagay ang thermocouple wire. dapat to nilagyan natin ng thermocouple putty o yung thermocouple cement. Kasi pag walang thermocouple cement yan, ang makukuha mong temperature, yung actual temperature ng heater. Ang dapat makuha mo, yun sa bakal na temperature. Ngayon, kung masyadong makapal yan, katulad ng ball mill nyo, mga 4 inches ang kapal, saan ba nang gagaling ang init? Nandito sa ceramic pad. So, may possibility na sa labas, 600, kung gusto nyo malaman kung uniform ang temperature dito sa ibabaw at saka dito sa other part of your ball mill, maglagay ka rin ng thermocouple wire dito. Kahit na wala ng heater, para malaman mo kung ilan ang inyong temperature recorder. Tandaan nyo, ang inyong machine, 6 channels. However, your recorder is 12 channels. So, pwede kang maglagay ng extra monitoring, ikabit mo sa temperature recorder direkta para makukuha mo yung temperature sa ibabaw at saka sa ilalim.
Okay po, sir.
Robert.
Next po, sir. Very basic question din po ata. Pag nasa flat surface yung crack, paano po ang setup ng heating elements?
Ano?
Paano daw po ang positioning ng heating elements kapag ang crack daw po ay nasa flat surface lang? Siguro plate po siguro sa yan.
Halimbawa, ito. Ang crack nandito. Tama ba, Robert?
Yes, sir. Opo. Nawawala po yung drone.
Wala yung drawing. May napindot ako. Ano ba yung napindot ko? Bakit ganun? Ito, nandito yung crack.
Yes, sir.
Okay. So yung crack naman, di ba, alisin natin yan. So maglalagay tayo ng stop hole. Di-drill natin. I-drill to. Tapos sukayin natin yan para ma-ensure natin na mawala yung crack.
Yes, sir.
Tapos, conduct tayo ng penetrant testing para sigurado walang naiwan na crack sa loob ng ating bakal. No? Ngayon, magre-repair weld na tayo. So, di, ano gagawin mo sa ating heater? Dito ilagay, gitna mo siya para yan. Kung gusto mo, lagyan mo pa ng backup na 2 heater sa 2 side. So, 3 heater. So, isang thermocouple wire, kabit mo rito. Tapos, isang machine nasa channel 1. Ito yung TC1. And ito yung control number 1. Yan, ganyan, Robert. Kala
Okay,
ko,
sir.
andyan na sila. Kala ko naturo na kayo sa site.
Opo. Ngayon lang po nila natanong to, sir.
Okay?
Okay po. Copy daw po, sir.
Any other question?
Wala na po dito sa chat. Kung meron pa pong gusto magtanong.
Anyways, doon sa mga gusto pa ng deeper lecture, the Philippine Welding Society is offering the Certified Welding Inspector course or CWI. You can inquire the Philippine Welding Society in order for you to know the complete process. Kasi itong dinidiscuss ko sa inyo about heat treatment. And sa welding inspection course or sa welding engineering na ino-offer ng Philippine Welding Society, all of these are being tackled, including selection of the different welding process, the selection of the correct material for a certain application, and the preparation of welding procedure and welding repair. Dinidiscuss yan. Wala namang problema if you're in Cebu, the training conducted by Philippine Welding Society is via Zoom also. Anyway, any other question pa? Sir?
So mukhang wala na po yata.
So with that, happy sana ako kung nakikita ko kayo, pero hindi nakita nakakita sa inyo si Ipong at si Robert. With that, I will end my presentation. And huwag kayong mag-alala, hindi naman natapos dyan. Any other questions, please email Robert, and I'll be happy to answer your question kung hindi masagot ni Robert. So the lecture proper is finished, and I hope you do more practice with your machine, and the training certificate will be issued by Robert, no, with regards to post-welding treatment. And thumbs up nga kung okay na kayo. Thank you very much. Okay, ito pala yan, nandito si Jen. Jen ba to, Jen? Thank you. Okay, maraming salamat din. Stay safe. Ito, maraming na pala nagpasalamat eh. So with that, maraming pong salamat sa inyo. I will end my presentation, and I hope with my own little knowledge, natuto kayo about the science in welding, the science in studying metal, which is metallurgy, and the different mechanical properties affecting your welding. With that, we would like to thank you, and God bless everybody. Thank you very much.
Thank you, Sir Gerald.
Sige po, to end the session po, maraming salamat po again from the participants po natin from Tayo. Yung certificates po na i-issue po, dun po, Ma'am Jing, kung nandyan po kayo, dun po sa na-request nyo po na i-issue natin ng certificate, ipoprovide na lang po namin. And again po, para po sa mga may kagustuhan ng in-depth training for PWHT, mag-inquire lang po tayo sa PWS. And yun, gusto nyo po ng in-depth knowledge. Again, maraming salamat po. I hope marami po kayong natutunan sa webinar this morning. Yan, maraming salamat po ulit. Bye-bye po. Sir Bong, may sasabihin pa po ba kayo?
Okay na, Robert. Thank you again sa tayo for dun sa ating training din ngayon. Thank you, Sir Gerald.
Okay po, sir. Thank you.
Thank you.
Bye-bye po. Thank you po.